Well, we're pretty confident we understand 5% of the universe, but that's about it really. The rest is a bit of a mystery. The 5% is the normal matter that you and I are made out of, that the sun is made out of, planets, stars, anything that we can see is made out of that 5%. But then we think there's a 20% of the universe that's made up of something called dark matter. And that's stuff that we think behaves rather like the normal matter that you and I are made out of, but is invisible. And it's invisible because it can only interact through gravity, not through other forces, and it can't interact with light. And then it gets worse from there on, because 75% of the universe seems to be made up of stuff that we just don't understand at all. And we call this dark energy, but if we're honest, we have no idea what it is.
Why do we think dark matter exists at all? What's the actual evidence for it?
There are a whole load of different lines of evidence for dark matter, and they range from things like the way that galaxies spin. We know that the way it spins is related to the strength of gravity within the galaxy, and the strength of gravity should be dictated by the total amount of stuff. So when we measure the way that galaxies spin, we get some measure of how much stuff is in those galaxies, and it's just a lot more than the amount of stuff that we can see. So there are things like that. Then there are other lines of evidence which get a bit more subtle. There's something called gravitational lensing, where light gets deflected by the gravitational field around an object. Again, it gives us a way to measure the total amount of stuff that's there, and yet again, it's more stuff than you can see directly. And finally, the cosmic microwave background, which has very distinctive ripples in it. And by studying the way those ripples appear in that remnant light from the Big Bang, we can work out what's in the universe. And once again, it gives us the same answer, that there must be about 5 times more stuff than we can actually see.
How did dark matter actually play a role in the formation of the universe?
As far as we can tell, dark matter has been absolutely critical to the way the universe we know today came into existence. The thing is that when the universe was born, it was very smooth. Everything was spread out very evenly. And to get to the universe today, where things are very lumpy, they're gathered together in these galaxies and with not very much in between, we need some kind of force to pull all the stuff together, and that is the force of gravity. But on its own, the force of gravity between all the normal matter that we can see just wouldn't be enough to form these galaxies. So we really need dark matter there to explain how the universe started from being smooth and kind of pulled itself together into the universe we know today.
Do we have any direct evidence for dark matter? Are people going and looking for it?
People have certainly looked for direct evidence for dark matter, and the situation at the moment is that there's no real confirmation that it's there. One way you can go and try and find it is to try and collect particles from space, because we think they're all around us, they should be streaming through the Earth, and if you build a big enough detector, just occasionally one of them will hit the detector, and maybe you can tell that something slammed into your detector. The problem is all sorts of other things are flying around and can hit this detector, so you have to be very careful before you can say that you've really seen dark matter, and that means it gets harder and harder as you try and make more and more sensitive detectors. And right at the moment, nobody can really say that they've seen any dark matter. There are possible claims. Maybe people have seen something, but it doesn't seem like anything very solid has come out.
And you're a theorist, as physicists go. What does that actually involve? I guess it doesn't involve actually going out and taking readings.
I'm a theorist, which means that I spend my days working with bits of paper and pencils, and occasionally, when I'm really lucky, I get to work with a computer. But I never actually go out to a telescope and start collecting actual light from the universe. Of course, it's critical that we understand what people are measuring about the universe. It's no use just locking yourself away and completely ignoring what we know is out there. But what I try and do is try and come to a sort of new understanding of what's going on by looking at what we understand about basic physics and let other people go and do the exciting stuff like climbing mountains and looking through telescopes.
Do you think the next major breakthroughs in physics are going to come from modelling, sort of thing that you do, or from observations?
It's very hard to predict where the next major breakthrough is going to come. It's a very hard game to get into. My feeling is that there are certain things at the moment, things like dark energy, that we just have so little theoretical understanding of, that any kind of breakthrough is likely to come in the theory, because in a sense, because we're starting from such a low baseline, we have so little understanding of it at the moment, that there's a lot of potential for somebody to come up with a better theory of what's going on there.
So you can't go looking for ways to prove something until you have a better understanding and a theory to go and get results for?
That's definitely right. It's very hard to construct good experiments before you have a specific theory that you're really trying to test.